Hello everyone, my name is Konyedi Olodu and you are welcome to my channel. The channel where we make structural engineering design simpler. And I want to welcome you once again to this platform. If you've not subscribed to our channel, please click the subscribe button, click the like button, share our videos, so that whenever there's a new video like this, you'll get notified and you'll be the first to benefit from it. Thank you all those that have subscribed, and those who are yet to subscribe, please subscribe. Thank you. Today we'll be talking about Pi foundation design. Pi foundation design. And I want you to stick to the end because there are some very important informations that I will be giving via this training that will be very beneficial to you. We'll be talking about Pi design, things that you need to look out for while doing your Pi design. We'll start straight away. We've done in our subsequent videos, in our previous videos, we've done the superstructure design. Now we'll be talking about this substructure design. So we'll just run through the superstructure designs. We'll not really talk much about it. Our main focus will be on Pi foundation. The first thing you need to ask yourself before you decide on Pi design is two things that will determine whether you are using Pi design or not. Is one, the bearing capacity of the soil. If the bearing capacity of the soil is not good, that even a rough foundation will not sit well on such soil, then the next foundation to do is piling, taking your foundation below the soil to get a firmer soil. If the soil at the surfaces are not too good, you need a Pi to take it down to where you have a firm soil. Or if you are building a high rise that has very large loads coming on the foundation, so you will need Pi to take care of that. So pay attention to those two. If your soil bearing capacity is not good at the surface, and when you drill down and you get a firmer soil below, you take your Pi to that. Thank you. Let's start. Like what we've always done, we'll just do a very quick one. The first thing you do, click your new project. We'll say okay, we are saying is Pi. That's what we'll name this file. Pi. I will say UK BS8110. We allow it few times. On this, we'll just pick this octagonal as its generator. You click on it. We'll use same products that they've given. So if we look at this is our axis line. So we'll go straight to our column. We are using let's say we use 300 by 300. Let's just use that because we'll be doing high rise. Or we say this we will be very fast. So you can check out my previous videos on this reinforced concrete design of the superstructure. It explains it more. So we've done the column. Next we do is our beam. Let's do 230 by 450. We will not really concentrate much on this. Two ways we can do it: we just alight, and once you alight, it will automatically connect your beams for you. We're done with this. Next we do is to create our beam wall load. Beam wall load, we say edit wall load. Edit wall load, we say 3.47 as and our height as 2.7, and the thickness of the wall we say 0.23, and we say okay. With that, we copy beam wall load. If I'm too fast, please go over our previous videos where I took my time to explain it very well. So you alight and you say paste copy beam load. Yes, it automatically pastes it. Now we want to generate the floors. We say this, we click on building setup, we say insert building. We are going 8 floors, meaning 7 floors plus the roof. We say okay, and yes, it has automatically done it for us. Go back to your story one. Please go over to our previous video for more detailed explanation. This we are just trying to get through and get our loading for the pie design. Okay, here we've not done our slab. Okay, let's connect our slabs. We said 150 slab, 150 slab. Okay, the load, we say this dead load, to point this, then we'll right click, say general, let's just say general or whatever. We click to get through to create our slabs. Yes, we've created our slabs. Okay, we can save our work. So when you work, just click save. So with this, we go back to building setup, we click generate story, we click generate story, and go back to generate story. We click on one, and we attached it to, we click on control, and we hold on to all the ones we want the property to be attached to. I'm leaving this last one. This is our roof. I will explain what I'll do with our roof. Previous videos explained it. So we say yes, we click yes. So it has completed it. Why on this one now? Because the roof doesn't have slab. We'll take out the slabs, anything about slabs, and we say okay. We say okay. It has completed it. Now if you look at this, this is our roof beam. On our roof beam, we don't want this wall load to be on it. Just take it out, delete beam wall load. We say yes. Is out. And the thickness of our beam here, we want it to be 230 by 300. So what do we do? Go here, just click this, click on shift and pick the last one, shift, right click on it. We say edit section stroke material. This will change it to 300, and we'll say okay. Okay, automatically it does it. Beautiful. So right now we come to this part, edit beam wall load. On our roof, we'll use the specific weight as 1, the wall height as 1, and the thickness as 230. We say okay. Please, for further explanation on this, I won't really explain much, but go over to our previous video. It explained it very well. So we click, we say copy, beam wall load, and paste. Yes. Okay, so we are good. We've gotten what we want. If you come to view, you can right click 3D and it will show you, yep, this is it. If you see it, this is our floor. This is how it would be. So we proceed, go back to plan, and we go to analysis to building analysis. That's the first place we go to, and we click on load combination, click load generator, and we click create unfactored G plus Q combined. Yes, we say okay, we close here, go to analysis, load decomposition, and we click on bash FE chase down. We say okay, and you give it some time to run the analysis on the slab. Just give it some time to run the analysis. Okay, it has finished running. Its beam has been calculated for. You click OK and close. Apply to all model. Good. Come back to analysis, building analysis. We'll come to edit material. All these are all okay. We just click on this rebar, column rebar. We need to pick the reinforcement we want to see in the columns. We need 16, we need 20, we need 25. That is what we want. The beam 2, we need 6. You uncheck the ones that you don't want. 16, we need 20, we need 25. You say okay. For slab, we need just 12, white 12. That is what we need. Uncheck, and uncheck all. We go to link. We need just white 10 for our links. We need just white 10 for our links. Yes. You say good. You say okay. So you're good. Come to analysis. We click column. We click beam, and you click start to run the analysis. So it's doing the design. We've analyzed, it's doing the design right now. So give it some time. So it will run all the floors from 1, 2, 3, 4, 5, 6 floors. So you just have to be a bit patient for it to run the design. Okay, it has finished. We say okay and we close. So if something we need for our design is the load on the columns, for we to see the load on the column, we'll come to this part, this very icon, click on it. It will pop this click column plan display. Click on Asia load. We come to here, pick the load combination we want to see inside. Just click. But the one I'm clicking is G plus Q factored. G plus Q. Just look at them and click. We say okay. With that, we are seeing our column positions, our column loads here. This is it. This is our column load positions. So if you look at these are very high values. So with this, we'll finish our subsurface design. So let's go over to the foundation level. So with this, you need now to design. If you do a design with pad on on this load it will be too big and not economical at all. So in terms of pie design, like what I told you, that I will tell you something that is very important in pie design. You can't design pie without the soil test reports. Very important. So your soil test report must be available for you to be able to do this design. And I will show you some reports that I have in doing some pie design. So we show you this. This is just an extract from the soil report. The soil report, which says executive summary. The client requested subsurface exploration and geotechnical engineering service for the site of proposed development along X states. All these informations have been taken out so that the site where we took this report from is anonymous. So the proposed project consists of high-rise building units and several blocks of triplets building units. Subsurface conditions at this subject site were explored by 8 comb penetrometer test points and 4 boreholes with standard penetrative resistance obtained at intervals. The report described the subsurface condition encountered in the exploration, present the test results obtained, and provide recommendation for the use in designing of the foundation. All relevant laboratory tests were performed in accordance with BS 1337 as stated in the laboratory results attached as appendix. So these are informations you need. They've gone to site, they've tested the area to know the condition of the soil. Now this is the investigation outcome. The site is predominantly underlain by loose poorly grained sand up to a depth of about 80 meters from the ground surface. So if you look very well, that almost from 0 to 80 meters has poor grade of sand. A strata of silty sand is found between 31 and 38 meters. Groundwater was encountered at a shallow depth of 1 meter in most places. So if you can see very well here, this will now be the length at which your pie will go into the soil to get a firm foundation. So the recommendation, rough foundation is recommended for duplex and triplets with multiple floor numbers of 4. A bearing capacity of 175 kilonewton per meter square is recommended at a depth of 1 meter, and a dry unit weight of 21.3 kilometer per meter cube observed. So with this report now, if you are doing a rough foundation or you are doing a floor less than 3 floors or 4 floors, this is what you use. But now let's see, they can be used in design of structural foundation. The depth of foundation embedded for the low-rise buildings should be at a depth of 1 meter below the natural surface. The structural engineer has the discretion to determine the most economic foundation type. So now this is where we come in. So for high rise, we are doing about 7 floors. Pie foundation type is recommended. The average comb resistance OC as determined along the depth of exploration is 2.3 MPa, while the average factored frictional resistance FX along the depth of exploration was 3.0 MPa. This can be used in the pie calculation analysis and design depending on the desired pie diameter at the discretion of the structural engineer. A ball pie of 31 meter depth is recommended. It's recommended. So with this, I know what to do or where to start from. I already know that my pi length will be nothing less than 31 meter. Nothing less than 31 meter. So further into the soil test report, they will have to come up so with this now we have the axial capacity of the pi for different diameters. If you look here, we have 300 pi diameter. So as we can see, we have a 300 pi diameter, we have 450, we have 600, and we have 800. So the different pi diameter has different bearing capacity of the pi. So if we look at 1 meter, 2, 3, 4, t, we got to 31 for this borehole 1 and 2, borehole 3. These are their different values. For 450 capacity, the more the diameter of the pi, the larger the capacity to carry load. So now from our drawing for our design, we are seeing 182 capacity to 29 column load. So if we now get to this pi, what they've done, let's see. If you look at this, at 31 meter depth, the capacity is 498, and this one is 682. So if we pick 450 to do that, it's not really recommended for us to use a tiny and not too large pi diameter to do very deep, go down very deep into the soil. So the best recommendation is from 600 and above. So at 31, our 600 diameter capacity is 806 or 1072. And we still have this, or 800 for 1326 and 1719. So but most likely, because of if the pi capacity is too big, you may not really have enough space. So I will say let's take 600 to do our pi design. So this is how you determine the length of your pi and the capacity of your pi based on your soil test reports. So this is very, very, very important. I can't overemphasize this. So with this, that we've known the depth we are going and our size of our pi, let's proceed. So the first thing we'll do is to determine the parameters of our pi. We come to settings, go to foundation design setting, we click on it. It will pop general, it will pop pi cap, it will pop pi. So let's click on pi cap to determine everything. The shaft now we say circular, yes. The depth of penetration 75 mm, we say yes. The size of our pi is 600, yes. Now the ultimate compressive capacity of our pi, from what we've seen, let's say we are taking 1072, say 1072. This will be our this, and then the default length of our pi will now be 31,000, yes. Then all these are just between pi to pi, it will be 2.5 times the diameter. So both pi, if you're having multiple pies on one place, the spacing between them must be 2.5 times their diameter. Okay, and the next thing we just need to work on will be number of pies. So we will say 1. From 1 we can combine 1 to 100. We say okay. So with this, you can right click and click insert pi cap. Insert pi cap. Give it some time, it will pop. Just give it some time. Okay, it's popped, so we just click on pi cap. Let's just define some parameters more. This will define circular, will define this, will define pi size, and our pi depth, our depth of pi. Pay attention to this. This is very, very important. We have a rule of thumb in determining the depth of our pi. The depth of our pi says 2 times d, 2 times the pi diameter plus 100. Listen very carefully. To determine the thickness of our pi cap, thickness of our pi cap is 2 times the diameter of the pi plus 100. So if we are having 600 as our pi capacity, it will now be 2 times 600, which will give us 120 plus 100 plus 100. So we are having our pi depth capacity as 113. Every other thing holds same. We're not changing anything here. We're not changing anything. After all, we click on design. We click on design, and that is what we will do. So you see, it automatically gives us our design. That is it. We already know our design. Then the other thing we can do, if we don't want to design it one after the other, what we do would be we highlight everything, right click, insert pi cap. Good. Once we are here, we can either do same thing that we've done before, change what you need to change, but we've already done that. So no need to do that. After this, we now say everything has been done for us. We say design all. It will automatically design all of them. It has designed all of them. So we can say okay and give it time. Automatically it does the design. It does our design just like that. It does our design very, very fast. So that is how we do design. Then you can take it to Prota detail for detailing, but we will not be talking about that. Maybe our next video we explain more about the detailing, but this is how you design for your pi. Your pi design has been done. Thank you. So if you save your work, if you have any question, please feel free to place it on the comment section. We'll be glad to answer it. But if you still not subscribed to our channel, Please click the like button and share, and also click the subscribe button, click the like button and share this video. And once you do that, more videos will be coming up and you will get notified. Thank you. So until we meet again, remain blessed. Thanks.